Let's suppose your class teacher has given you an assignment in which you have to design a circuit in which identifies the number of students entering into a class. Entering in a classroom, right? Now, how you will design a circuit like this? To design a circuit like this, you implement your logic like this way. Let's suppose initially there are no students in the room, right? There are 0 students. So you start from here, right? As soon as one student enters, you add a 1 to it. So the total count now becomes equal to 1, right? Then when the next student enters, the count becomes 1 plus 1 equal to 2. Let's suppose a student goes out of this classroom. Then what the count becomes? It becomes the previous count was 2 and then minus 1 and then 1, right? If you notice the pattern carefully, you will see that your result 1 or 2 or 1 here, it depends not only on the current input. The current input was 1 because one student has entered, but it also depended on the previous output, right? The output from the previous stage. A circuit in which the output depends on the current input plus the previous output is called to be a class of a circuit called sequential circuit, right? Now, what can be another example of a sequential circuit? I'll say a next example of a sequential circuit can be your counter in your stopwatch, right? Why is it so? Because this also implements the logic that you have designed it earlier. This also starts from 00000000. As soon as 1 second passes by, this increases, and another second this increases to 2, and so on and so forth. So let's see how we can design a circuit of this type. You have seen from the from a combinational circuit or from your previous readings that a combinational circuit was those classes of circuit in which the output depends on the current input, right? You give a input to a circuit and you get a output for that. For example, your multiplexer, your adder, you have supplied a particular input, you have given 0 and 1, and you have directly got a output as 1. You didn't need a output for the from the previous stage to calculate here, right? So you saw that to implement a sequence a combinational circuit, you needed just a input and an output. Now if you have to implement a logic like the previous example, how you would do so? You need some sort of storage element, right? You need some sort of storage element, so you can store that the output from the previous stages, right? And what will be the connection structure of this all thing? You are giving a output, input, you are getting a output, you are storing this output, and then you are feeding that output back into your circuit, right? Without, let's say, without this without this storage element, this was combinational circuit. Now as soon as you have added this combinational circuit plus the storage element, what does this become? This is nothing but your sequential circuit, right? So officially this is the circuit diagram of a sequential circuit, in which you give a particular input and you bring back the feedback from the previous stage and you have the current output. Let's reiterate the previous example which we have given. Initially it starts with 0, right? No students was in the classroom, and you have got the output of 1. So for the previous stage you are getting 1 as your output. Now this 1 as an output is stored here, right? Now this one comes here and you supply an input of 1, because in the next stage another student comes here. So this 1 plus 1 becomes 2, right? For the next stage the output is 2, and so on and so forth. I think sequential circuit is clear as of now. In the next lecture we'll see. So in this lecture we have seen that what is a sequential circuit, example of sequential circuit. In the next lecture we'll see how we can design this storage element, because if you notice carefully, you already know how to plug an input and get output. You basically know how to design a combinational circuit. If we can design this memory or storage element, we can officially go on designing a circuit for largest circuitry, right? So in the next lecture we'll see how we can actually design this storage element.